Hello everyone, and today we will see one question of UPSC Civil Service 2021 uh, 10 marks question that is from heat transfer. So here all the notation that is given, so I'm not writing the data again, I'm just highlighting that data. So a plain wall of thickness 0.4 meter, thermal conductivity is given and surface area is given. The left side of the wall is maintained at constant temperature 80 degrees Celsius. Okay, let me clear this. Okay, area 20 meters square, T1 is equal to 80 degrees Celsius, and right side of the face loses the heat by convection, and atmospheric temperature is 15 degrees Celsius, TA. So T1 is given as 80 degrees Celsius, atmospheric air is given as 15 degrees Celsius, and with heat transfer coefficient H is equal to 24 watt per meter square degree Celsius. Assuming constant thermal conductivity and no heat generation, we have to find the variation of temperature, the relation of variation of temperature within this wall, and also we have to find out the heat transfer through the wall. So what we have to do is, for that, first of all we have to find this temperature, the second T2 temperature, and for that we have to take one assumption, that is a steady state heat transfer. So for steady state heat transfer, what happen, whatever heat is conducted throughout the slab, so we can write the equation Ka T1 minus T2 divided by L. It is same amount of heat is convected in the atmosphere, that is Ha T2 minus T infinity. Okay, so A will get cancelled. Put the value of thermal conductivity, that is 2.3 divided by, sorry, T1 is 80 minus T2, length is 0.4 meter, H value is given 24, and T2 minus T infinity, it is 15 degrees Celsius. So when you solve this, you will get temperature T2 as 27.56 degree, 27.56 degrees Celsius. So this is one relation, one parameter that we got. But what we have to find is temperature relation. So generalized heat conduction equation, we can write it gradient of delta square of T plus Qg by K is equal to 1 upon alpha dt with dt by d small t. Here let me tell you the meaning of this notation. T is equal to temperature, Qg, that is heat generation, K is equal to thermal conductivity, alpha is equal to the diffusivity, and small t here it represents time. So now here it is written no heat generation, that means this term will get cancelled out, and steady state we have assumed, so this term will get cancelled out. So we have only one term, that is del square t. But here one more thing that we have to assume is 1D heat flow. So our equation will get reduced, d square t by dx square is equal to 0, and we have to take x from this left wall. We can take x is equal to 0 from left wall, and x is equal to 0.4 from x equal to 0.4 at right hand side wall. So d square t by dx square is equal to 0. So integrate it, you will get dt by dx is equal to c1. Again integrate it, you will find t is equal to c1x plus c2. Now we have two constants c1 and c2, but we have two boundary condition. Like at x is equal to 0, that means on left side wall temperature is 80 degrees Celsius, and x is equal to 0.4 meter, temperature we have found 27.56. So we can write x at x is equal to 0, temperature will be 80 degrees Celsius. So put this in equation 1, let me write as equation 1. So you will get the value C2 is equal to 80. Now at x is equal to 0.4, temperature is 27.56, that means temperature is reducing. So C1, put value over here, so you will get C1 is equal to minus 131.35. So the generalized equation that we can write is T is equal to minus 131.35 x plus 80. So this is the answer of our first question, that is obtain a relation of temperature across the wall. Now second thing that we have to find is the heat transfer rate. So heat transfer rate, it is given by HA delta T, that is T2 minus T infinity, or similar we can say that Ka dt by dx both will be same because as the flow is steady state. So H value is, we have 24, area it is given as 20 meters square, and temperature difference, that is 27.56 minus 15. So when you solve this equation, so you will get the answer of heat transfer in watt. So you will get 6028.8, 6028.8 watt. But if you want to write in kilowatt, so 6.03 kilowatt. So this is the amount of heat transfer. So this is answer of our second question, and you can secure 10 marks here. So I hope you like this solution. And one more thing, that the frequency of video may get vary, like one day not come, one day come, but this, all the things will be get stabilized. Okay, so don't worry about it. And thank you for watching this video, and keep connected with this so we can continue our this series more and more. So thank you for watching this video, and once again, enjoy your day.